Today's session will be a debug session. I'm trying to debug why the number of agents wasn't consistent, and I found that that's because we may be symbolizing the agent names because we created an object where the keys are those strings of the agents, but then we deep symbolize what's coming from the front end, and we shouldn't do that because it'll create unique keys, random keys, which is not good. So here I am fixing that. Now on the space server, what's everything that touches an agent? So we get an agent spawned at this point. The event is going to be, and let's look at the type, agent spawned, and you're getting a P with a name and a position. And here is a string. Okay, so when we go to stash this in space server, we are putting it in a map, and this is a string, so that's fine. This is a string, unalterated, and position gets symbolized there. That's fine. Agent spawn. Agents redirected. Payload I've changed a bit. So let's take a look at how we're creating agents directed. First of all, the type I changed a little bit because it was an object, but now it's an array, and that's because I don't want the string here to be an object key, because that deep the randomness in the key will cause many atoms to be produced. Then the place where we're creating them should be here in this function where we're generating these things. So we calculated the future positions by iterating through all the agents that we know about, grabbing their current position, which may not be totally accurate. You probably want to use where the mesh is. So you probably could do current position is agent mesh position. That's the current position, probably is better. Then you get a random point around this, maybe within 2 meters or something. Calculate a delay, which right now let's just say happens immediately. I was doing that for testing. Let's do math random within. Do this a little bit random, a little bit of randomness, and we hard code this down into the payload. Then we reduce it into an array. But since all of this is already an array and we want to pass an array, we don't need to reduce, we can just map over the temp payload. We don't need this, and we just want to return a payload that takes current position, next position, comma, delay is the temp delay, and the name is still agent name. What? Oh, I have delay up here. Sorry. Delay is yes. Oh, okay. This can be temp name. And that can be our future positions. And we'll send that agent's future positions. And we're sending it out, so this might have a slight delay because incoming is faster than outgoing. So if we want to be totally in sync with this, we can add some synchronization here, but let's make that a to-do. And also, what were we doing with agent spawn? Spawning is also sending to ourselves. So let's write that as a next is improve sync timing by making leader and everyone else receive agent commands near the same time. Might be hard, but let's see. Okay, so now we're sending agents directed. So if we go back to space server, this is now going to be agents, and this is an array, not an object. So we can map through this. Or I guess we can reduce through this. Reducing through agents, which is a map. Map of what? It's a map of, it's a list of agent. So we can just say agent. And then we can map put into the accumulator, which is the agent states the, and so we don't want to use the agent name. Now we can use agent dot name. This is a string. And then we create agent dot current position. Yes, that should update the position. So that should fix the issue with symbolize or atomize and also string keys. Because we're putting this as a map of strings and then we return it, it should just be fine. Everything should be fine. Let's test. So restarting the server, clearing memory, coming back to our space. Let's enter the space. And we get one agent, and the agent is directed to move, and we get an error. Missing agent for 0. Okay, what does that mean? We need more information. Missing agent for 0. This doesn't tell me, but we know it happens with the directed business. Agent manager. We're getting set timeout. Start spawning, create agent. Where is it? Yes, here. Okay, let us. Yes, it's this thing. Object keys. Because this isn't a no. This is our agent stash. This agent's The agents directed is sending agents. This looks fine. Current position, delay, agent name, next position. That all looks fine. So it's possibly in the parsing. Oh yes, parse, parse, parse. We didn't handle that yet, did we? So we need to handle the agents directed, which right now agents is this, and this was expecting an object here, but really it's just a list. So you can just do for each. For each agent here, you can do if this, if first you have to find it. So if this agent and then agent dot name, if you can find it there. Otherwise, you don't have anything for this agent. And we need to find the agent index, which is agent name, agent index, and then the destination is agent, next position. Seems to like this more. Then you say this crowd go to agent index and the destination with agent delay. Alright. Okay, they're both being asked to move. Seemingly sort of independent, that looks fine. And if I refresh this, we should get 3, I think. 1, 2, 3. And if we try to remember where they are, and then I refresh again, it doesn't seem like they really retain their positions very well. Oh, that's because mesh position, it doesn't have a position. We have to use the transform position. Right. Agents directed. Yes, agents directed. This part here, we should probably use agent transform position. That might work way better. Alright, remember there are all these positions, and refresh. Okay, a little better. A little bit better. Okay, alright, we have 1, 2, 3, 4, 5, 6. So if we load Firefox, we should also have 6. This Firefox. Let's see. 1, 2, 3, 4, 5, 6. Number is correct, but they're nowhere near as closely related as they were before. And these two are okay. This one's sort of, but they're quite out of sync. And I think that's because of the network delay. So what if we tried fixing the network delay? Close this and close this. Network delay. So anytime first let me save some changes. Oh yeah, I can check something. Agents. Yep, they're all string keys now. Perfect. And git commit fix extra agent bug caused by atomized agent name. Now we want to make it more closely synchronized. So when we send this, let's just send it out. So start spawning. This agent spawn will only send out, and the what else? We'll only send that out. Start spawning, and then the movement will also only send this out, because we want to use the same delay that we're giving everybody else. We don't want to get it too fast, because the network could be an extra 50 milliseconds or 100 milliseconds. Then let's go to the gen server and handle this cast. So if we handle this cast and we're doing handle event, so the tuple has our PID. And if we remove the PID, it will just broadcast to everybody. This is because handle event, it takes this, but this broadcast event gets that PID, and then if it's nil, you'll broadcast to everyone. Otherwise, you broadcast to self. So all we have to do is modify that tuple in agent directs here. So we get this PID here, and this tuple can just be the same tuple, except you need to override that last element in there, which is a little tricky to do here. Is there another way to pass this? Elixir tuple change one element. Put element inserts a value into a tuple by index. So if you have this tuple insert at, actually adds an element into the tuple. Okay, example. Insert at 2. Oh, you want to avoid, you want to, okay, Adam. put element 3. Okay, so let's say we have a tuple with 1, 2, 3, 4, and that's tuple. Then I want to use tuple put element for t, and at the index 0, 1, 2, 3, and change that to a 5. Is that just a, where is this? Put elem. Okay, that works. So I think that's what we want to do. Handle event put elem tuple for the 1, 2, 3, 4. Wait, 0, 1, 2, 3, 0. Agents directed, and also agent spawned. Same thing here. Put elem tuple third nil. 0, 1, 2, 3. Yeah. So that should allow us to get the message all at the same time. See if it works. Alright, let's put this on the left. Bring us at Firefox. This is looking pretty good for 1. It was off a little bit in the beginning. So let me refresh the leader. So now we all get 2. The leader's position is a bit off. Even the collision is handled pretty smoothly. We're in sync. Let's refresh again. Okay, the locations of these meshes are way off. To kind of get to the same place now. Okay, so it remembered the last place that they were in, but as this thing continues to move, these are outdated. That's why. And I guess that's fine. When you come in, you should expect a reasonable bit of out of syncness. But as you continue, these look pretty good here. So now we've got 4. Let's refresh some more. Do it again. Out of sync in the beginning, and then still out of sync. And now I think we've caught up. So the leader should probably kick in immediately. The leader should not wait to 5 seconds right now as it is. And let's see, so that's in the agent manager. This is waiting 5 seconds. Let's just wait 500 milliseconds. Or even less, maybe just 50 milliseconds. Oh, no, this is the set interval. How often we want to do it. So why don't we set it first? So we'll extract this to a function so we can call it immediately. We'll call this send agent movements, and that'll be this. And every 5 seconds, call this send agent movements, but also just call it immediately. So we'll get our leader in there. Still a bit off. Okay, now it's kind of in sync. That sort of has to do with us not knowing where to place the initial position of the enemies, because we're using the current position to place them, but they have next positions that they're going to, and we don't know how far to interpolate them. So one thing we could do is we could, when creating them the first time, we move them there and not need to wait for the instruction. We'll just immediately also send them in a direction if we had cached that information. For example, if in Agent Manager we're planning these movements, so we're sending agent movements, which is this rich set of things. We have the name, current position, next position, and a delay. That when, let's say we get about, we can get there let's not call it current position. Let's call it previous position because we have no idea where it is. So replace current position. Is that all related to these types? And here, current position, current, yeah, agent space server, agent current position. Call this previous position. Oops. Current position, and replace this with previous position. Here, go ahead and replace that. In the space server, previous position. So let's store this as previous position, and also, why not just store the whole thing? The whole state. Except the name. Yeah, I can do that. So we get the agent. Sure. Map.delete the agent and the key, which will be name. So you get that. Now let's handle the agent's directed listener. No. We need to handle the about agents listener. About agents. It's going to have a different key now. Agents manager. Yep, here creates any previous font agents, and you're going to get a whole bunch of stuff. And it's not called position, it's called previous position. Yes, and the type has changed. Type for an about agent is not here. It's in Signal Hub. About agent. About agents becomes, yes, it's this, and yes, it is previous position. Also next position. So certainly you're at some tween between here. We don't know what the tween is. But this is the action that was previously acted on. So you could just send them all to their next positions. Put them all here, drive them here, and you might actually get there ahead of other people. So that's the about agents type. Maybe we want to use the delay, I'm not sure. Delay can be a number. May not use this, but if we go to the handling of the about agents, which is here, incoming, create an agent, and we'll use the previous position, but then immediately, once the agent is created, also move it. So this crowd agent go to with the agent this agents, give me the agent name, and I'll give you back the agent index. And what do you want to go to? You want to go to Babylon vector 3 from array of the agent dot next position. So immediately as we're creating it, we're going there. And I'm hoping this helps things out. So load this one, and it creates, cannot read property, reading of 0. Where was that error from? Vector 3 agent manager on this line. God, I can't see. Agent manager line 18. Line 18. I'm not sure what's going on. Let's add some debug. About agents, you get this, which is a payload of the string to that. Let's just check that it is. So console.log about agents, and you, this is the payload, right? About agents, agents as an agents key, and all of these agents, and some of them just have positions, some of them has other things. All right, let's clear the slate first. And throw that in here. let's do this. Okay, no errors there. 2 and 3. And he's caught up very fast. That's good. So what if we were just from the console issuing new outgoing messages? What if we just said signal hub emit outgoing emit event, and it's of type message is agent spawned, and the payload just has a name, right? Let me just check the type of this. Just a name and a position. Okay, so we have a name, which is whatever, and a position, which is, let's just put it at the origin then. So if we did this, how would this look? We'll go bleep. I think something crashed because I entered twice. Yeah, here's a crash. What was this? Int to Atom for agent spawned. Oh, I can't use a string. Of course, I must use the number 7000. Let's restart our server. We'll refresh this space. Enter as a leader. And let's refresh this space as well. Okay, it's catching up. Taking a slightly different route to get to a certain location. Now it's still not caught up, or maybe it is. I'm a bit far. So in this leader, I will say agent spawned, not agent spawned, the number 7000. Ready. And go. And change the name out. Go. And they're fighting there. And go. 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 It's pretty good. Once you get synchronized, they look okay. And if I just refresh this person here, get their current locations. It's not too bad. It catches up pretty quickly. Okay. It's not perfect, but I'm satisfied that it is an optimization of these messages that we have here, where all of these are in one message for all agents instead of many separate messages. I'm pretty happy with this. So I'll make a commit here.